Dad, why has this iron rod turned like this?
It's rusted. Iron reacts with atmospheric oxygen and moisture to form iron oxide, which is commonly known as rust. Metals react with other elements in a variety of ways. Metals burn in the presence of oxygen to form metal oxides, which are basic in nature. For example, if you burn a strip of magnesium, magnesium will burn in oxygen to form magnesium oxide. Magnesium oxide dissolves in water to form magnesium hydroxide, which is basic in nature. Similarly, when a copper vessel is exposed to moist air, a green coating forms on its surface. The coating formed is a mixture of copper hydroxide and copper carbonate.
At last, I found them.
What are these? Oh, iron nails.
These nails got rusted too.
Yes, the nails have rusted because of the moisture present in air. Metals react with water, but all metals do not show the same kind of reactivity. For example, sodium reacts vigorously with water and oxygen and produces so much heat that it catches fire. That's why sodium is stored in kerosene to prevent it from coming into contact with moisture and oxygen. Let's try an experiment. Take a trough. Fill half of it with water. Now, carefully cut a small piece of sodium and dry it using a filter paper. Then, wrap it in a small piece of cotton. Place the piece of sodium in the water trough. You will observe that sodium reacts vigorously with water, catches fire, and moves about in the water, making a hissing sound. So now you understand how much heat is produced in the reaction. When you introduce a red litmus paper, it turns blue, indicating that the solution formed is basic in nature. Be careful. You should stay away from the water trough during the reaction. It gets very hot.
What are you doing here, Father?
I'm cleaning this tap with a lime peel. The tap is looking dull because of the deposits of calcium salts in water.
Ah, the tap is shining now. How did that happen?
Lime juice contains citric acid. Acids react with salts of metals. The citric acid of the lime juice reacted with a calcium salt on the tap, and now the tap is clean. Metals react with acids such as hydrochloric acid and sulfuric acid to give out hydrogen gas. Let's take 4 different metals: magnesium, iron, aluminium, and copper in 4 different test tubes A, B, C, and D respectively. To these test tubes, we add 5 milliliters of dilute hydrochloric acid or sulfuric acid using a dropper. We can now heat the test tubes gently using a Bunsen burner. Hydrogen gas is liberated. But how do we know it's hydrogen? To test the gas, we introduce a burning splinter near the mouth of the test tube. The splinters put off with a pop. It shows that the gas is hydrogen. From this, we can conclude that metals react with dilute acids and liberate hydrogen gas.
Do metals react with bases in the same way that they react with acids?
Yes, the reactions are quite similar. Metals react with bases such as sodium hydroxide to produce hydrogen gas. Let's verify this with an experiment. Prepare a fresh solution of sodium hydroxide in a test tube by dissolving 3 or 4 ballots of it in 5 milliliter of water. Into this solution, drop a piece of aluminium foil. We now bring a burning splinter near the mouth of the test tube. The splinter is put off with a pop. This shows that hydrogen gas was produced.
In depth, the reactions of metals with acids and bases are quite similar, but you mentioned that some metals, such as sodium, react more vigorously than others. How do you know that?
Let me show you an interesting experiment. Let's take 5 beakers A, B, C, D and E. Let's take copper sulfate in beaker A and B, drop some zinc granules in beaker A and iron filings in beaker B. Take zinc sulfate in beakers C and E, drop copper turnings in beaker C and iron filings in beaker E. In beaker D, take some ferrous sulfate solution with a few copper turnings. Now note that the blue color of the solution in beaker A has disappeared. This is because zinc replaces copper from copper sulfate. In beaker B, the solution turned green. This is because iron has replaced copper from the copper sulfate solution. There's no change in the other 3 beakers C, D and E. This brings us to the end of the detailed session on metals, their appearance, behavior and uses in our day-to-day life. When you make a bonfire, the wood burns to release smoke. Nonmetals react with oxygen and form acidic or neutral oxides. For example, sulfur reacts with oxygen to form sulfur dioxide, which is acidic. Take a small amount of sulfur in a deflagrating spoon and heat it. As soon as the sulfur starts burning, introduce the spoon into a gas jar. Then cover the jar with a lid. To ensure that the produced sulfur dioxide gas does not escape, remove the spoon after some time. Add a small quantity of water into the gas jar and quickly replace the lid. Shake the gas jar well. Sulfurous acid is formed. Now introduce a blue litmus paper which turns red. The sulfurous acid turns the blue litmus to red. Observe the bonfire. Why? In this bonfire, there is a partial combustion. Carbon monoxide is produced. This is a neutral oxide. Nitric oxide is another example of a neutral oxide. We don't need the fire anymore. Let's put it out. The fire is gone, but the unburned charcoal is left behind. That's true. Generally, nonmetals do not react with water, though they may be very reactive in air. Such nonmetals are stored in water. For example, phosphorus is a very reactive nonmetal. It catches fire if exposed to air. To prevent the contact of phosphorus with atmospheric oxygen, it is stored in water. Yet, another important property of nonmetals is that they do not react with acids. Let's look at this small experiment. Take sulfur powder in a test tube. Add 2 to 3 ml of dilute hydrochloric acid or dilute sulfuric acid. There's no observable change. Unlike acids, bases do react with nonmetals. Reaction of nonmetals with bases is complex. For example, when chlorine reacts with a base like sodium hydroxide, it gives multiple products like sodium hypochlorite, sodium chloride, and water. It was very interesting to learn so much about nonmetals. Now I will be able to identify the properties and uses of nonmetals.